5.8, sketching graphs of derivatives and also sketching Okay, as a hint when we do these, the value of f prime is the slope of f. So we're going to start out on example 1, given the graph of f and then graph f prime, although we're more likely to do the opposite. Okay, this is the graph of f. Remember that f prime is the slope of f. So I can see f is linear. Is the slope positive or negative? Negative. The slope is negative. Slope is negative, and the slope is actually a constant negative value. If you were to guess what the slope value is without a scale, I have no idea. Maybe negative 1/2, but the slope is constantly some negative value. So f prime is going to look something like this. I don't know if that's -2, negative 1/2, negative 1/3, but the slope is going to be some negative value. Okay, let's consider b, which is more interesting. Okay, this is the graph of f. The slope is varying. I can see it starts out positive here, it's negative over here, it's a little bit flatter over here. So this is not going to be a constant graph anymore. Okay, let's do the easiest points first. Let's consider the relative minimum or maximum values. So there's a relative maximum right here. If that's a relative max, it's a critical point. What is the f prime value there? It's 0. So if I go down to my f prime graph, f prime should be 0 right here. Okay, let's look on the left of this graph. Okay, if I start out here, is f prime positive or negative? It's positive because it's increasing. And it's like kind of steep, and I don't know what it is. It might be like +2, +1. Okay, it's still positive here. It's still positive here, but it's not quite as steep anymore. It's flattening off. It's positive, positive. It's still positive here, but barely positive because it's about to go to 0. Now, once I pass this relative maximum, it switches to negative. So now it's negative, 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 becomes more and more negative. So as I cross this point, my slope changes from positive to negative. So it's going to look like this, something like this. And we don't have a scale because we don't know exactly the values because there's no scale, but this is a good sketch. I know it's 0 here because of the critical point, and then it changes from positive to negative. Okay, let's look at C. Okay, we'll start with relative maximum minimum. Okay, there's a relative maximum here, relative minimum here. So that means that this is probably 0 around here. This is 0 around here. Since this is a relative maximum, the slope is changing from positive to negative. So I know it's going to do something like this. If this is a relative minimum on f, then the slope is changing from negative to positive. So I know it's going to go something like this. Okay, so let's make this work. So it's going to go something like this. Eventually it's going to come down here and it's going to go back and it's going to go up here. Okay, if you want to consider one other point, we can consider the concavity. This is concave down, this is concave up. So right around here somewhere, there's a point of inflection, which is where the graph changes from increasing to decreasing. So on my graph, it looks like it's around here. But f prime changed from decreasing to increasing, or concave down to concave up. But this is a good sketch. I got the critical points, and I have them correctly changing from positive to negative at the relative maximum and negative to positive at the relative minimum. Okay, now we're going in the opposite direction. They're going to give us f prime. We're going to graph f. When we do this, we cannot get a very exact graph. We don't know the location. We can only get some key points of it correct. So we're going to consider relative minimum or maximum, increasing, decreasing intervals, and concavity. Okay, so on the last graph, we looked for a relative minimum or maximum because that told us f prime was 0. So instead, I'm going to say, okay, look for where f prime is 0. F prime is 0 right here. And f prime is changing from positive to negative. So if f prime is changing from positive to negative, what does this tell me? It tells me there's going to be a relative maximum at x equals 0. I don't know exactly what's going to happen there. So at x equals 0, I'm going to draw some kind of relative maximum. Okay, and then I know it's going to go something like this. And that's my good enough sketch for me. This kind of makes sense too, because the graph of this is negative x squared plus something. The derivative of negative x squared is negative 2x, which could be this line. So that's a decent sketch. Okay, let's look at a more complicated one. Let's look at B. Okay, let's see. Let's start with the same thing as last time. Let's look for critical points equal to 0, f prime equals 0. So right here, there's a critical point. Right here, there's a critical point. Let's figure out if those represent relative minimum or maximums. Okay, so f prime changes from negative to positive. So that's going to represent a relative minimum. So at x equals negative, what, 3 point something? There's going to be some kind of a relative minimum, and I don't know where it is. So let's just make a guess and say it's going to go something like this, and I'll fix it later. Okay, at x equals 1 point something, there's another critical point, and f prime is changing from positive to negative, which means this is what? Relative maximum. So there's a relative maximum of 1 point something. Don't know how high it is, don't know what's going on, so let's just put it here and say it's going to look something like this. Okay, is there anything else we could consider? We could consider this point right here. This is where f prime changes from increasing to decreasing. So this is a point of inflection. So since this is f prime is increasing, it was concave up, and then around there it changes to concave down. So let me think about this graph. Okay, it does start concave up on this side. And then somewhere around -1, it's going to change to concave down. So if this were my point of inflection, it's going to change concave down. So I'm going to reconsider this just to make the graph easier to draw. Okay, so now it's going to go concave down. And then where was my relative maximum? At 1 point something. And then my relative maximum is at around here. Okay, so now I have my relative minimum in approximately the right place. I have a relative maximum about the right place. And there's a point of inflection right around here. So it went from concave up to concave down. And then that's a good sketch. Now the location, I have no idea how tall or short it is. So this could be moved down, up. The humps could be higher or lower as long as it has the correct key features. Okay, one more. Okay, this is f prime of x. We're making it more complicated. But let's start with where f prime of x equals 0. Or if it didn't exist, I would also use those. Okay, this just tells me how to start it. Okay, so what do we have? F prime changes from negative to positive. So what is that? A relative minimum. You have 1, 2, 3, 4, and -5. And I don't have any idea where it is. So I'm going to sketch it and then I'll fix it later. Okay, at 0, f prime changes from positive to negative. So there's some kind of maximum. I'm going to make it higher. And then on the right, f prime changes from negative to positive at 1, 2, 3, 4. 1, 2, 3, 4. I have no idea where it is, so I'm randomly drawing it. Okay, so I can already tell this is going to go something like this. Okay, so I might as well include concavity because I can see the points of concavity. So points of inflection would be here. So right around here, it's going to change inflection. So let me make this graph look better. So concave up, and now it's going to switch to concave down. Okay, and then when does it switch back to concavity again? Right around here. So right around here, I'm going to switch it again. Okay, and that's a pretty good graph. I got the relative minimum maximums, and I checked for points of inflection. And your graph can look different as long as it has the same features as this graph.